In the previous video, we finished the chapter 1 with the whole subchapters of the computer structure and systems, right? From this lecture, we will learn about the new concepts with the chapter 8. However, as you know, we already touched the concept of each chapter already in chapter 1. So maybe you are familiar with the terminologies and the flow concept. But in this video, we will use the Linux with C programming language. So please take a look all by yourself with your region notes and your the portal as well as your own portfolio Word file. All right. So as you can see on the screen, we will learn about processes and exceptional control flow step by step. Maybe we will touch the process concept and the C programming language with the process generation, with the difference between the processes, processor, and the software, hardware component. All right. Okay. So the contents, terminologies, kernel shell and utilities, processor and processes, process control, exceptional control flow, exceptions. And we will touch the VI editing command for C program language on top of Linux. So as you can see the right side of the chapter 8 of our English textbook, I modified my materials with the chapter 8, but I tried my best for helping the non-major students with the processes concept first, and we will go to the exceptional control flow. So I changed the sub-chapters of the original chapter 8 of our English textbook, but don't worry about it, okay? Okay, so you are familiar with this figure and terminologies already because we had enough time in chapter 1, right? So can you differentiate the software and hardware clearly? If you do that, you are successful for my lecture, okay? So different from other software or programming language lectures, as you know, in this lecture, we learned about the hardware as well as the software, so cooperation between them, right? So most parts, if you visualize and look at some components, maybe they can be hardware, right? Such as CPU, the I/O bridge, main memory, USB controller, including the mouse, keyboard, and the display with the monitor and disk and so on, right? So even though we did not take a look each hardware component with our desktop or laptop, but we already watched each component with enough time with my lecture slide as well as your English textbook. Okay, so these are most parts of hardware, right? So please imagine how can we order our wish to each hardware component. As I mentioned many times, because of OS, operating system. With the help of the operating system, we can order or make or touch the hardware components as well as their missions, all right? So in this lecture, we will touch the principles in detail. Okay, so did you remember main memory, each space? We will touch this concept in detail in future, so don't worry about it. But I recommend you are familiar with these specific the space name as well as the location of the each space of the main memory. For example, as I mentioned, the kernel virtual memory is the top level of the main memory. So have you ever heard about the kernel? The kernel is the main part of operating system. So this concept is a software. So we will learn kernel in detail in the next page. Okay, so maybe before learning the kernel concept, with this figure we can imagine, oh, kernel is the queen or princess among the spaces of the main memory, right? Because the location is top level, right? So kernel virtual memory is the top level of the main memory, and then we can consider user stack. And when you take a look bottom of the main memory, these are related with the general code, such as the hello.c. Alright? So please remember each terminology of the main memory space as well as the location. So please close your eyes and remind the terminology with the location all by yourself many times. Top level is the kernel virtual memory and user stack and memory mapped region for shared library such as printf. And then the bottom parts start with the runtime heap and the read-write data part and read only code and data. Okay, so these can be loaded from the hello executable file. Okay, so please take a picture this page also and repeatedly check your portal in your cell phone every day. Okay, we can go to the next page. Okay, this page is very important because even though most students learned the computer structure and system, but someday they can forget each exact definition of kernel, shell, utility. Okay. So with these good English sentences and right to figures, you should compare each cases and memorize the exact definition and the deep meaning of each terminology. Okay. So before talking about each English sentence, please compare two figures of the right sides. The right bottom figure, there are main memory and only one user, right? User A. However, the bottom figure, there are two users, all right? So at that time, how can kernel control each person independently? So how can we connect the Linux very efficiently? So these sentences are related with all user, single user. These sentences and paragraphs are related with the multi-user system. Two or more users can be connected in the same Linux simultaneously and efficiently. All right. Okay. So if we connect the PuTTY application program for the first time, or if we connect the if we turn on our laptop or desktop, such as Windows or Mac, maybe system boots for the first time, and the kernel is first loaded into the main memory on the top level, as we checked the figure in a previous slide, right? So, and then if the user powers on the terminal, such as PuTTY or other related with the program called the shell is loaded in the memory on the terminal too. The shell then waits for user to enter a command on the keyboard. For example, if we click the terminal and the host name with this port, if we opened the shell request or require the secure ID and password, right? And that means such as the cursor, right? The cursor waits for the user to enter comments on the keyboard, right? So when the user enters a comment, such as ls, the shell fetches the utility corresponding to the command from disk and run it. All right? So even though we already familiar with the PuTTY and login and VI editing commands a little, these are possible because of kernel, all right, and shell and utility, all right. So please compare these real time the connection with this figure, all right. In this figure, user A is me, 하영-O, right? So if 하영-O turn on the window, the kernel is loaded on top of the main memory, all right? And then if 하영-O opens the shell program also loaded into the main memory, all right? And wait for my comment in the shell screen, all right? So after understanding my comments, the shell followed the results for the after execution, all right? So as you can see on the right figure, the kernel is the first program to be loaded into memory, okay? And shell help the user for the commands, the execution for proper the mission, all right? Sometimes I can make the VI the new file or editing, all right? Or I can just check the old files in the current directory like that, all right? So how kernel, shell, utilities are related is the content of this slide, all right? Okay, and the second figure is related with a multi-user system and various users. The relationship between these three programs, such as the kernel, shell, and utility, is formed whenever power is turned on from each user. All right. So user A can also efficiently use the shell with the utility on top of the kernel. User B can also use the Linux similar to the user A. Each user cannot know each other. They can be served independently and perfectly in the same Linux system. Alright, so Linux is very famous for covering multi-user in the multi-user system. Okay, so in this case, kernel can make each process for each user, and they can control independently and efficiently. Alright, so for example, first terminal powers on, such as the first terminal is putty, right? First terminal powers on if the user A powers on the first terminal on top of their own desktop, kernel, the Linux kernel in the 성균관 University or other place, but the same server, can create the shell immediately for the terminal and help the making process based on the commands of the user A. Similarly, if user B connects the Linux server with their own putty program on top of their own desktop or the laptop, the Linux server can help the user B immediately for the proper result. Alright, so regardless of the number of users, the Linux can help each user very efficiently. So each user can type a command properly, and the Linux kernel can create their own process with the child process concept. So child process concept can be touched in detail in the next slide, so don't worry about it. The new terminology is the child process, and this concept can be expressed with this style of the figure. Alright, so in these slides we talk about what is the kernel, shell, and utility. Alright, so what is the kernel? Since the kernel is the core part of the operating system, as I mentioned, the role of the kernel can also be said to be a core role of the operating system. So we can think operating system as kernel. Alright, so you are familiar with these kinds of figure because I already mentioned many times, right? So several applications such as putty, KakaoTalk, Word file, PowerPoint, Explorer, Chrome, many kinds of applications can use the hardware independently on top of operating system with kernel. Alright, so kernel can help the secure and resource management, as well as the hardware abstraction. So kernel can support the applications about the secure uses of each hardware. So this concept is related with security, and the hardware resources can be managed efficiently on top of kernel for application, and each application believe, oh, I can fully occupy the CPU, hardware, memory, and so on. So each application have its own illusion. That is hardware abstraction concept. Alright, so if we touched each definition in detail with this slide, I can summarize each concept with the main parts of each paragraph. The security. The kernel is responsible for the security of the computer hardware and processes, as I mentioned. And kernel can manage limited hardware system resources efficiently and makes program execution smooth. In particular, assigning a handler to a process is called its scheduling. All right. So every day, whenever you watched my video or take a look my materials, please remind the difference between hardware and software. All right. How about kernel and operating system? These are software, right? But how can we touch the hardware in detail? Because of kernel. The kernel can control hardware. So kernel program is a very difficult concept and very complicated for general programmers. All right. So maybe with the technical terminologies such as the scheduling and the handler, the kernel can cooperate with the hardware with the promise or appointments, the handler and scheduling. All right. So that is one of the advanced techniques in OS and system programming. So maybe we can shortly touch these concepts too. But if you are interested in these part more, please connect personally to me, and you can refer chapter 3 and 4 of our English textbook. Okay, and last concept of the kernel law is the abstraction. All right. As you know, direct access to hardware can complicate matters very much because different hardware can be designed for the same kinds of components. In general, kernel is implemented with several hardware abstractions, such as a set of common instructions for the same kinds of equipment. The kernel tried best to hide the complex interior of the operating system and provide a clean and consistent interface to the hardware. All right. So that means hardware abstraction help programmers develop programs that works on multiple machines. The hardware abstraction layer, abbreviation is HAL, relies on software drivers that provide specific instructions for the manufacturer's equipment specifications. All right. So with three factors, kernel can cooperate with each hardware on top of sophisticated scheduling. So applications can have its own illusion for the fully occupied hardware usage. Okay, so please take further these slides and periodically check your portal as well as the writing in your written note for yourself. All right. Sometimes some students ask me, Professor, can I write down each slide comfortably in my written notes? Of course, you can do it. Even though I recommend or mentioned the main parts or necessary parts of each slides in your written notes, but the most important thing you should understand and you should learn for yourself of my lecture, right? So please use your written notes comfortably for yourself and the records or put the starting traces very comfortably. There's no format or no mission. But sometimes I request, please write down 2 or 3 times in your note for yourself. At that time, please the put your own star or specific the shape with the color pencil for yourself and me, and then you can take photo and paste in your Word file, and then please upload your portfolio Word file whenever I request in the iCampus of the assignment menu, right? So I can check the diligence trial of each lecture per week, and I can prove each student the trial for the university system manager. So these students followed my lectures very well, and I can give the final score with this diligent proof as well as the midterm and final test score and so on. All right. So for the proof and your own understanding, please use your written notes and Word portfolio file as well as your portals. Okay, thank you. Okay, so we will move to the process concept in the next video. So please memorize the new terminologies of this video, such as the kernel, shell, utility, and the role of the kernels with the 3 factors, such as the security, resource management, and hardware abstraction. All right. In the next video, we will cover processes and the C programming language together. So please prepare for your written note and your cell phone as well as Word file. Okay, thank you. See you next video soon. Bye bye.